Welcome back, everybody. Our last section for Unit 2 is on function operations and composition of functions. So let's talk a little bit about operations and their domain. If they're asking us to find the sum, they're asking us to add. And so we can write it as either f plus g of x or f of x plus g of x. And basically what we're doing is combining like terms. The difference means to subtract. So you can either write it as f minus g of x or f of x minus g of x. Product means to multiply. So remember, when two things are right next to each other with no plus, minus, or division symbol, it means to multiply. And so this is f of x times g of x. And then quotient means division. And so we would divide f of x divided by g of x. And we have to make sure we note that g of x cannot equal 0. The domain of the sum, difference, and product functions are all real numbers, or in interval notation, that would be negative infinity to infinity. The domain includes the same for the quotient function, but has to exclude any values in which the denominator is equal to 0, which are those restrictions that we talked about back when we first started these domains and ranges. So let's try some. If we have f is x squared plus 1 and g is 3x plus 5, find the following. Well, this is asking us to add them. And it's saying take x and change it to 1. So we can do 1 squared plus 1 for f plus 3 times 1 plus 5 for g, and then do our order of operations and find our answer. Starting with the f function, we have 1 squared is 1. 1 plus 1 is 2. 3 times 1 is 3. 3 plus 5 is 8. 2 plus 8 is 10. So this answer is 10. F minus g of negative 3 now says, okay, take x and change it to negative 3. And from there, subtract the answers you get for each. So we have negative 3 squared plus 1 for f. We're subtracting because of this right here. 3 times negative 3 plus 5. Negative 3 squared is 9. 9 plus 1 is 10. That's for f function. G function, 3 times negative 3 is negative 9. Negative 9 plus 5 is negative 4. So now we have 10 minus negative 4. Add the opposite, gives us 14. So our final answer is 14. For C, this is asking us to plug 5 in for x's in both G and F, find their answers, and multiply the answers together. So for F function, we have 5 squared plus 1 times G function of 3 times 5 plus 5. 5 squared is 25. 25 plus 1 is 26. 3 times 5 is 15. 15 plus 5 is 20. Now find the product of that, or multiply them together. 26 times 20 is 520. So the answer to that is 520. And then the last one is asking us to find the quotient, or divide. So plugging 0 in for x on the f function, we have 0 squared plus 1. And then plugging 0 in for x on the g function, we have 3 times 0 plus 5. On the top, 0 squared plus 1 is 1. 3 times 0 is 0. 0 plus 5 is 5. And so this answer is 1/5. I don't have to worry about any restrictions because in my answer, I don't have any x values there. So there's no worry about the denominator being 0. All right. The second set of examples. Starting with f plus g. We're leaving x in there, so that means we have f, which is 8x minus 9, plus g, which is the square root of 2x minus 1. We can't actually add those two together, and so 8x minus 9 plus the square root of 2x minus 1, that's as good as that's going to get. This is the answer of them being combined with adding. Their domains. So their domain is restricted by the square root of 2x minus 1. Remember, that can't be negative under the radical or it's not real. And so when we did these before, we said, well, to find out where my domain starts, we would take that and set it greater than or equal to 0, because that would ensure that we have 0 or a positive number under the radical, and we'd have a real answer. So add 1, and then divide by 2, and x would have to be greater than or equal to 1/2. So this domain is a bracket because of the equal to, goes from 1/2 to infinity. For part B, f minus g. So we again have our f function, and then now we're subtracting our g function. Well, remember, we can't simplify that any further because I can't actually subtract the radical from these. There's no like terms there. So our answer is just going to change by making that a subtraction instead of an addition. For our domain on letter B, it is still restricted by that radical. And we've already solved for how that radical changes our domain. And it says, well, I can start my graph at positive 1/2. So 1/2 in a bracket to infinity in parentheses. For C, it's asking us to multiply. So when we multiply these together, they're really just sitting next to each other. because again, I can't distribute here and do any combining of like terms, all because of that radical. So our final answer of this one would be this. Our domain still has the same restriction with that radical, and so we still have a domain of 1/2 to infinity. Letter D. Letter D is going to change just slightly. They're asking us to find the quotient or divide them. And let's see, let's pick blue here. So we have 8x minus 9 divided by the square root of 2x minus 1. Now we would rationalize the denominator here, but because we haven't really reviewed that yet, we're just going to leave this alone for now. Our domain is still restricted by this radical. But how this is different is for all of our other ones, we said, well, it could be equal to 0. Well, now it can't equal 0 because it's in the denominator. Oh, let's try spelling that again. Denominator. Sorry about that. So if it's not equal to 0, then we have 2x minus 1 is greater than 0. So we still have the 1/2, but the difference is rather than a bracket, it's a parenthesis for our domain because it cannot be equal to. All right. So what happens if rather than given equations, we have these instead? So let's start with A. For A, it's asking us first to add F and G when we make F4 and G4. So if you go back to how we did this before, we find where x is 4, 1, 2, 3, which is here. If I match it up to G, this is G. Sorry, I don't know why the labels weren't on there, but let's go ahead and add our labels there. This blue line here is G, and then the maroon line there is F. So matching 4 up to this line for G and taking a look, that Y value is 2. And then if we match it up here to F and find that Y value, that's 9. And so 2 plus 9 is 11. So for example A, F plus G of 4 is 11. All right. Second, they're asking us to find F minus G of -2. Well, -2 is here for x, and it looks like it's going to join up on our f function as -3. But for g of -2, the graph doesn't exist there. So I'm going to put DNE, does not exist. If it does not exist, then f minus g of -2 does not exist. It's undefined. We can't find the answer. The next one they're asking us to find is f times g of 1. 1 and 1. So here is x is 1. For g, that answer is 1. For f, that answer is 3. So f times g of 1 means we're going to do 3 times 1. Oops, I wrote the answer there. 3 times 1, which means it's 3. And last but not least, they're asking us to find f divided by g when x is 0. So let's do purple. Here is when x is 0. So for g, that is also 0. For f, we're at 1. F over g means the 1 has to go over 0, which we can't do. It's undefined. So f over g of 0 is no solution, undefined. What happens if we're given a table? Well, this makes it a little bit easier. If we start with f plus g of 4. Here's where x is 4 on our table. F is 9, g is 2, 9 plus 2 is 11. So our answer is 11. F of g of negative 2, here's negative 2, and we're subtracting. Negative 3 minus undefined, well, that's undefined. It does not exist. We can't find the answer to that. F times g of 1, so when x is 1, f is 3, and g is 1, so 3 times 1 is 3. Then we have f divided by g of 0. So here's when x is 0, we have 1 divided by 0, which is again undefined or no solution. Does not exist. C is the equations that are represented by the graph and the table. And so just another way to see that each one has either 11, does not exist, 3, or undefined. So for f, when we're adding f plus g, you have 2 times 4 plus 1 plus the square root of 4, because it's asking us first to plug 4 in. So we have 8 plus 1, which is 9. The square root of 4 is 2. And 9 plus 2 is 11. Now, if we are subtracting and using the equations, and they're asking us to plug in negative 2, we would have 2 times negative 2 plus 1 minus the g function is the square root of negative 2. Well, as soon as I see this, I'm going to say, nope, I can't do it because the square root of negative 2 is imaginary. Yes, I can pull an I out, but I can't actually graph it. And so there would be no real solution for this. For the multiplying, when x is 1, 2 times 1 plus 1, here's the f function, times g function is now the square root of 1. 2 times 1 is 2, plus 1 is 3. The square root of 1 is 1, and 3 times 1 is 3. And then last one is the division. And it's asking us again to divide and make x 0. So 2 times 0 plus 1 over the square root of 0. 2 times 0 is 0, plus 1 is 1. The square root of 0 is 0. Nope, that can't happen. That's undefined. No solution. We are going to skip over the difference quotient for right now and head on over to the page with composition of functions and their domain. So composing a function is like putting one function into another and then simplifying it. So we have f of g of x, or you might have heard this called fog of x. The open circle means composition. Now, right here is going to be a very important note card. Make sure you pay attention to the difference between f closed circle g of x, which is multiplication, versus f open circle g of x, which is composition. That should go on your note cards. That's super important. All right. The domain of all of composed functions includes all numbers in the domain of g and f. Also has to satisfy f. So we're still having to be careful of radicals and rationals. So example 4. Find fog of 2. So remember, this also means f of g of 2. Now, if you remember working with grouping symbols, we start on our inside and work our way out. So on the inside of this, it says, hey, first find g of 2. Okay, so this says, look at your g function and plug 2 in for x, find an answer. So 4 over 2 minus 1. Remember, f is still there. We haven't done anything with the f function yet. 2 minus 1 is 1, so 4 divided by 1 is 4. So now that we've done this, we have find f of 4. So plug 4 in here to the f function. 2 times 4 minus 1. 2 times 4 minus 1 is 7. So f of g of 2 is 7. G of f of negative 3. So again, working our way inside out, our inside says, hey, start with function f and plug in a -3 for x. Okay. So that's g of 2 times -3 minus 1. Well, that's -6. -6 minus 1 is -7. And so we have g of -7. Oh, well, now this says take -7 and plug it in here for g. Cool. 4 over -7 minus 1. That's 4 over -8, which is -1/2. So that makes this final answer, g of f of -3 is equal to -1/2. Our next one. Now we have some equations. So f of g of x. We start with g of x. So x says we're not changing anything. So the only way to replace this is, what is the g function? Well, the g function is 4x plus 2. So we're replacing g with the function that it is. Now it's saying, take this x in the f function and make it this instead. So the square root of 4x plus 2. I can't simplify any of that. Again, this x here says when you give me an answer, x should still be there somewhere. And so my final answer for this, f of g of x, is the square root of 4x plus 2. We put one function into the other and created a new one. Now we're going to go with the opposite direction, g of f of x. Okay, g of f of x. Start with f of x. So this x says x stays in there. What is the f function? Well, the f function is the square root, the square root of x. So then this square root of x says, okay, take this x and change it to the square root in here. So 4 square root, I'm not sure why I keep wanting to write 2. Apologize about that. Square root of x plus 2. Well, I can't really do any simplifying but to write them right next to each other. So our final answer, g of f of x, is equal to 4 times the square root of x plus 2. That's as good as it gets. All right, let's take a look at this last set. So fog, f of g of x. F of g of x says, okay, leave x in my equation because I still see x there. And what is the g function? Well, the g function is 1 over x. Wonderful. So now this says change x in the f function to 1 over x. All right. So 6 over 1 over x minus 3. This is messy. We're going to leave it like that for right now and say our final answer then of the composed function is 6 over 1 over x minus 3. Now let's go the opposite direction. Now we have g of f of x. So this time, what is the f function? Well, the f function is 6 over x minus 3. Okay, so this says take this and plug it in here for the g function. 1 over 6 over x minus 3. And there's our final answer. Yes, there's more that we should do with that, but for right now, we're going to leave it alone. We're going to hold off on the domains for those for right now. And let's move on to our next one. Show that, and I would star this because this is going to be something that will be on your test. Show that g of f of x does not equal f of g of x. Show that they are not the same. Okay. Let's start with g of f of x. So what is the f function? The f function is 4x plus 1. This says take that 4x plus 1 and plug it in for every x in the g function. Okay. 2 times 4x plus 1 squared plus 5 times 4x plus 1. So we need to simplify this. Please, please, please remember that you cannot just distribute a square when we have adding stuff in here. This really means 4x plus 1 times 4x plus 1. And then when we're done with that, multiply by 2. We can distribute over here. 5 times 4x is 20x, and 5 times 1 is 5. I'm going to do this multiplication first, foiling. When I FOIL that, I get 16x squared plus 8x plus 1. And then distribute the 2. We have 32x squared plus 16x plus 2. And we still have all this stuff over here. Combining like terms now leaves us with 32x squared plus 36x plus 7. And that is g of f of x. Now if we come over and do f of g of x, we start with, well, what is the g function? The g function is 2x squared plus 5x. So take that g function and put it in for x right there in our f function. We have 4 times 2x squared plus 5x and then plus 1. So the 4 and the plus 1 here come from the 4 and the plus 1 there. Let's simplify. I can distribute the 4. We get 8x squared plus 20x, and then we still have that plus 1. I have no other like terms there to combine, and so if I take a look at these two equations, they are nowhere near alike. So we have now proven that they are not the same, and it does matter the order that these are written. Well, if we can put functions together, then how would we pull them apart? This is an example of an already composed function, and they said, okay, well, if I know that to find that, I plugged some function g into some function f. What was function f and what was function g? Well, the clue here is to look at what's inside the parentheses. And what's inside the parentheses here are x squared minus 5. So it looks like we plugged in x squared minus 5. If indeed that's what we did, and we made that x, and we have a 3 there, and that became an x again, then that means our f function was x cubed minus 4x plus 3. Let's try that again. This is saying we did f of g of x. We put a function g into function f and wrote this new part. So where's our parentheses? Our parentheses are here. Those two are the same. And so 3x plus 2 is what was plugged in for function f. So if I take that out and make that x, I have a 4, an x, and a squared minus 5. That goes back to x, and then minus 8. So our f function was 4x squared minus 5x minus 8. All right, this is where we're going to stop for this. Thank you so much for joining me again today. Have a wonderful evening.